Let us now compare the various consistency conditions for regular register, sequentially consistent registers, and linearizable registers. So we'll go through some examples, and then we will define some properties of sequential consistency and linearizability. So here is the first example. So we have an execution here. This execution is regular execution. As you can see, both these reads overlap with the write, and the first read returns the value of 5, but the second read returns the value 0, which is a property of regular registers. But this execution is not sequentially consistent because sequential consistent traces do not allow this behavior of on the same process you return the value 5 and after that you return the value 0. There is no single sequential execution or trace that can give this result. What about this execution of a regular register? This execution is regular but also sequentially consistent. In a sequential consistent execution, it is allowed to return this read and also to return this read. We order the operation so that the first operation is the read that returns x equal to 0. Then after that we do the write operation, and then after that we do another read operation that returns the value 5. So in sequential consistency, operation precedence, in this case these two reads, is not observable if they appear on different processes. Sequential consistency only requires that operations on the same process are executed in that order. Now, here is a sequentially consistent execution, but in fact it is not regular because regular consistency does not allow this read to return the value 0 because this read happens after the write operation, means that the invocation of this read happens after the response of the write, and regular consistency requires P2 to return the value 5. At this point we have seen executions that are sequentially consistent but not regular, and here we have seen executions which are regular but not sequentially consistent. So now let us compare linearizability with regular execution and with sequentially consistent executions. So here is again a regular execution that we have seen before, but linearizability disallow these two operations to happen in that order with these results. So here operation precedence in linearizable execution is observable on the same process. So this execution is regular but not linearizable. So in a sense what we are saying is that there are no single storage that could behave this way. And here is another example where we have seen it also before, and this execution is regular again before these two reads are overlapping with the write, but they are not linearizable. Linearizable operation mandates this operation to happen after this operation. So operation precedence is observable among processes. So we have seen executions that are regular but not linearizable. We have seen executions that are sequentially consistent but not linearizable. And we have seen executions that are regular but not sequentially consistent, and vice versa. So there is then a consistency hierarchy that we can show in this figure, which says that any linearizable execution is also a regular execution, and any linearizable execution is also sequentially consistent, but regular execution and sequentially consistent executions are incomparable. So this ends the comparison between these three consistency conditions.